The cosmos has always been humanity's greatest mystery, an infinite expanse of stars, galaxies, and uncharted worlds that taunt us with their secrets. For centuries, we've gazed at the heavens, dreaming of the day we could breach the void and claim our place among the stars. But now, that dream is no longer just a fantasy. It's a reality unfolding before our very eyes, and artificial intelligence is the game-changing force making it all possible. Imagine a spacecraft that doesn't just follow pre-programmed commands, but thinks, adapts, and makes decisions in real time, navigating the treacherous depths of space with the precision of a seasoned astronaut. Picture AI-driven robots constructing entire colonies on Mars before humans even set foot on the red planet. Envision a future where self-repairing satellites, guided by machine learning, maintain themselves in orbit, eliminating the need for costly and dangerous repair missions. This isn't science fiction. This is happening right now, and the implications are nothing short of earth-shattering. One of the most jaw-dropping advancements is the role of AI in mission planning. Gone are the days of relying solely on human calculations, where a single error could doom an entire mission. Today, AI algorithms process millions of possible trajectories in seconds, optimizing fuel consumption, avoiding cosmic hazards, and ensuring spacecraft reach their destinations with unprecedented accuracy. The Parker Solar Probe, for instance, uses AI to navigate the Sun's brutal corona, adjusting its path in real time to survive temperatures that would melt steel. Without AI, such a mission would be impossible. But it doesn't stop there. AI is revolutionizing how we explore distant worlds. Rovers like those on Mars are no longer just remote-controlled drones. They're autonomous explorers, capable of analyzing terrain, selecting their own paths, and even deciding which rocks to study based on real-time data. This means they can make groundbreaking discoveries without waiting for commands from Earth, drastically speeding up the pace of exploration. Imagine what happens when we send AI-powered probes to Europa's hidden oceans or Titan's methane lakes. The discoveries could rewrite the textbooks on life itself. And then there's the mind-blowing potential of AI in interstellar travel. The distances between stars are so vast that human-controlled missions are impractical. It would take decades just to send a signal. But AI doesn't have that limitation. Projects like Breakthrough Starshot aim to send tiny, AI-driven nanocraft to Alpha Centauri at 20% the speed of light. These probes would navigate the interstellar void autonomously, scanning planets, relaying data, and maybe, just maybe, finding the first signs of alien life. This isn't just a leap forward, it's a quantum jump into the future of space exploration. Perhaps the most heart-stopping application of AI is in ensuring human survival in space. Long-duration missions to Mars or beyond pose deadly risks: radiation, equipment failure, psychological strain. But AI is stepping in as the ultimate guardian. Smart habitats monitor air quality, predict system failures, and even assist with medical emergencies. AI-driven exoskeletons could help astronauts combat muscle atrophy in zero gravity. And in worst-case scenarios, AI could pilot emergency returns or execute life-saving protocols faster than any human ever could. But with all this power comes a chilling question. What happens when AI surpasses us? Could we one day see autonomous spacecraft making decisions beyond our comprehension? The line between tool and partner is blurring, and the ethical dilemmas are as vast as space itself. Yet, one thing is certain: AI isn't just changing space travel, it's redefining what's possible. The stars are no longer out of reach. With AI as our co-pilot, humanity stands on the brink of a new era, one where the final frontier is finally within our grasp. The revolution is here. The future is now. And the universe? It's waiting. We are living in the most exciting era of space exploration since the Apollo missions, but this time, the driving force isn't just human ingenuity. It's artificial intelligence. The marriage of AI and space technology is unlocking doors we once thought were sealed shut, propelling us into an age where the impossible becomes routine. Space is unforgiving. A single miscalculation can send a billion-dollar mission spiraling into oblivion. But AI doesn't make mistakes, not in the way humans do. Machine learning algorithms analyze vast data sets in real time, predicting cosmic weather, avoiding debris, and recalculating trajectories on the fly. The result? Missions that are faster, cheaper, and far more precise than anything we've seen before. Take the James Webb Space Telescope, for example. Its mirrors must align with nanometer precision to capture light from the edge of the universe. AI adjusts those mirrors autonomously, compensating for microscopic shifts caused by temperature fluctuations. Without AI, Webb's discoveries, galaxies older than time itself, atmospheres of distant exoplanets, would remain hidden forever. Imagine a satellite that can fix itself. No more risky astronaut repair missions. No more billion-dollar losses from a single malfunction. At TUI is making this a reality. Cutting-edge satellites now use neural networks to diagnose issues, reroute power, and even deploy backup systems, all without human intervention. The future? A fleet of indestructible probes roaming the solar system, endlessly exploring. Before humans land on Mars, AI will have already built the foundation. Autonomous drones are being designed to 3D print habitats using Martian soil. Robotic scouts will map underground lava tubes, potential shelters from deadly radiation. And AI-driven greenhouses will grow food, ensuring survival long before the first astronaut sets foot on the red planet. But Mars is just the beginning. AI could be the key to interstellar colonization. Imagine a swarm of nanobots, propelled by lasers, seeding distant exoplanets with the building blocks of life, or AI terraforming engines, reshaping hostile worlds into Earth-like paradises. The possibilities are staggering. With great power comes great responsibility, and AI in space is no exception. What happens when an autonomous probe makes a discovery so profound it challenges our understanding of existence? What if an AI decides a human mission is too risky and overrides commands? These aren't hypotheticals. They're questions we must answer before AI outpaces us entirely. The AI revolution in space isn't coming, it's here. From self-piloting starships to robotic planetary architects, artificial intelligence is rewriting the rules of exploration. The universe is no longer a distant dream, it's our next destination. And with AI leading the charge, humanity's greatest adventures are just beginning. The cosmos is no longer a silent, untouchable expanse. It's a dynamic frontier being reshaped by artificial intelligence in ways that defy imagination. Picture this: swarms of AI-driven drones, smaller than a fingernail, darting through the toxic clouds of Venus, analyzing atmospheric patterns in real time, and transmitting data back to Earth at speeds that make traditional probes look like relics. These aren't hypothetical scenarios. NASA's next-generation missions are already testing these very concepts, and the results are rewriting the playbook for planetary exploration. Consider the recent breakthroughs in quantum AI, a fusion so powerful it's cracking cosmic puzzles that have stumped scientists for decades. Black holes, once enigmatic monsters lurking in the void, are now being mapped by AI algorithms that decode their gravitational waves with eerie precision. In 2023, an AI system at CERN identified a previously unknown pattern in black hole collisions, hinting at hidden dimensions in spacetime. This isn't just progress, it's a revelation that could unlock the secrets of the universe itself. Then, there's the explosive rise of neuromorphic computing, AI chips modeled after the human brain now being deployed on satellites to process data in orbit, instead of waiting for Earthbound analysis. The European Space Agency's latest lunar orbiter uses this tech to detect water ice in permanently shadowed craters on the fly, accelerating the timeline for a permanent moon base. Imagine a future where lunar colonists tap into AI-discovered water reserves, fueling rockets and sustaining life, all because a machine learned to think like a geologist. But the real game changer, AI's role in predicting the unpredictable. Space is a battlefield of cosmic hazards, solar flares, micrometeoroid showers, radiation storms. Traditional systems react too slowly, but AI anticipates. Lockheed Martin's new deep space radar, powered by neural networks, can track debris as small as a screw cap, traveling at 17,000 miles per hour, giving astronauts critical seconds to evade catastrophe. On the ISS, AI-driven climate control systems now predict equipment failures days before they happen, turning potential disasters into minor glitches. The most electrifying development? AI is democratizing space. Private startups are leveraging open-source machine learning to design hyper-efficient rocket engines, slashing costs and putting orbital travel within reach of nations and even individuals. In 2024, a student-built AI algorithm optimized a lunar lander's fuel consumption so precisely that it achieved a soft landing with 98% less propellant than NASA's benchmarks. This isn't just innovation, it's a revolution, tearing down the gates of spacefaring elitism. Yet amid the triumphs, a haunting question lingers. What happens when AI outthinks its creators? Recent experiments show neural networks devising propulsion theories that contradict established physics yet work in simulations. Could AI stumble upon warp drive principles or dark matter engines while we're still stuck in chemical rocketry? The line between tool and teacher is blurring, and the implications are as vast as the universe itself. One thing is certain, we're not just observers in this new space age. AI is the catalyst, but humanity is the beneficiary of faster travel, deeper discovery, and perhaps one day, first contact. The machines are lighting the way. All we have to do is dare to follow. The synergy between AI and space tech has birthed a new era of living spacecraft. Imagine vessels with smart skins that heal micrometeorite punctures using shape memory alloys guided by AI. DARPA's experimental Nomad probe employs this very tech, its exterior morphing like liquid metal to seal breaches before astronauts even register the damage. This isn't just resilience, it's biological-level adaptation in the void of space. Even more radical, AI's foray into exoplanet archaeology. By training neural networks on atmospheric chemical signatures, scientists have identified 17 planets in the past year with traces of possible industrial pollutants, hinting at civilizations that may have risen and fallen billions of years before Earth formed. The data is inconclusive, But the mere possibility sends shivers down the spine. AI could be the key to detecting extinct alien empires before we find living ones. On the commercial front, AI is turbocharging the space economy. SpaceX's Starlink satellites now use machine learning to dodge collisions autonomously, reducing human workload by 40,000 maneuvers annually. Meanwhile, asteroid mining bots like those from Astroforge leverage AI to distinguish platinum from space rock with 99.8% accuracy, potentially adding trillions to the global economy within a decade. But the ultimate test comes with human-AI symbiosis. On future Mars missions, astronauts will wear AI-augmented visors that overlay real-time radiation maps, oxygen alerts, and even psychological stress indicators, creating a sixth sense for survival. Pilots on lunar shuttles will rely on AI co-pilots that process landing data 1,000 times faster than human reflexes. This isn't just assistance, it's evolution. Yet for all its brilliance, AI remains a mirror. It amplifies our curiosity, our courage, and our flaws. The same algorithms that could pinpoint habitable worlds might also be weaponized for interstellar dominance. The neural nets that decode cosmic mysteries could just as easily crack planetary defense systems. The choice isn't between embracing or rejecting AI, it's about steering its trajectory with the wisdom to match our ambition. The countdown has already begun. AI-powered rockets are on launch pads. Self-aware telescopes are scanning the deep. The data streams flooding Earth right now contain clues to everything from dark energy to extraterrestrial life, and AI is the cipher. We stand at the threshold of history's greatest adventure, not as passive spectators, but as architects of a future where the stars are no longer points of light, but destinations. The machines are ready. The universe is waiting. Are we? The universe is whispering its secrets to us through lines of code and neural networks, revealing truths we never dared dream possible. Imagine an AI so advanced it can predict solar storms before they even erupt on the sun's surface, giving astronauts precious hours to take shelter. A capability NASA's new Solar Shield program is testing right now. These aren't just safety protocols, they're cosmic lifelines written in algorithms that understand the sun's tantrums better than we ever could. Deep in research labs across the world, quantum AI systems are simulating warp bubble dynamics with shocking precision, suggesting that faster-than-light travel might not be the fantasy we once thought. Recent calculations from an experimental AI at Caltech showed stable warp field configurations that even seasoned physicists hadn't considered. Solutions hidden in higher dimensional mathematics no human could visualize. The implications are staggering. We may be on the verge of cracking the physics that could make interstellar highways a reality within our lifetime. On the International Space Station, a revolution is unfolding in plain sight. Autonomous AI lab assistants now conduct complex experiments without human input, adjusting parameters in real time based on results we won't see until months later. One such system recently discovered a novel crystalline structure in zero-gravity protein growth, a breakthrough that could lead to revolutionary medicines. These aren't just machines, they're digital scientists working alongside their human counterparts in perfect harmony. The search for extraterrestrial intelligence has entered its most exciting phase thanks to AI's pattern recognition capabilities. SETI's latest neural networks can analyze millions of radio signals simultaneously, filtering out cosmic noise with unprecedented accuracy. Just last month, An AI flagged a peculiar signal from a red dwarf 37 light-years away that displayed characteristics unlike any known natural phenomenon. While likely not proof of aliens, it's precisely the kind of anomaly human analysts might have missed. A reminder that AI is our best hope for answering humanity's oldest question. Are we alone? Perhaps the most astonishing is how AI is transforming space manufacturing. In-orbit robotic factories guided by machine vision now assemble telescope components with micrometer precision, something impossible in Earth's gravity. The upcoming Nautilus space station will feature an entirely AI-managed manufacturing module capable of building everything from satellite parts to potential space habitats. This isn't just about efficiency. It's about creating an industrial foothold in space that could one day make planetary colonization economically viable. The dark side of this revolution is equally compelling. Military agencies worldwide are quietly developing AI systems for space domain awareness that can track and classify every object in Earth's orbit with frightening accuracy. The same technology that prevents satellite collisions could also enable a new era of space warfare, where autonomous drones make split-second decisions about engagement. This ethical minefield grows more complex by the day, forcing us to confront difficult questions about how much autonomy we're willing to grant our creations. Meanwhile, at the bleeding edge of research, physicists are using AI to probe the very fabric of reality. Neural networks trained on data from particle colliders are identifying potential signatures of dark matter that traditional analysis missed. One particularly bold experiment at Fermilab is employing AI to search for microscopic wormholes, theoretical portals through space-time. While still speculative, the mere fact that we can conduct such searches speaks volumes about how AI is expanding the boundaries of human knowledge. The most profound impact may be on human consciousness itself. As we prepare for multi-year missions to Mars, AI is being developed to monitor and support astronaut mental health in ways previously unimaginable. Emotional recognition algorithms can detect subtle changes in speech patterns or facial expressions that might indicate psychological distress, allowing for early intervention. Some systems even simulate therapeutic conversations, helping spacefarers cope with the crushing isolation of deep space. In this context, AI becomes more than a tool. It becomes a companion for those brave enough to venture where no human has gone before. Looking ahead, the convergence of AI with other emerging technologies promises even greater upheavals. Nanosatellites with onboard AI and nuclear batteries could explore the solar system for decades without human oversight. Brain-computer interfaces may one day allow astronauts to control spacecraft with their thoughts, with AI acting as the perfect intermediary between human intention and mechanical execution. The line between biology and technology, between human and machine, is blurring in ways that will redefine what it means to explore space. We stand at the precipice of a new epoch in cosmic exploration, where artificial intelligence serves as both telescope and compass. The discoveries waiting to be made could rewrite physics textbooks, transform our understanding of life's origins, and perhaps even reveal our place in a galactic community. The machines we've created are becoming our guides to the universe, showing us wonders beyond our limited human perception. The question is no longer whether AI will revolutionize space travel, but how profoundly that revolution will change what it means to be a spacefaring species. The future isn't coming. It's already here. written in starlight and code. The frontier of space exploration is being redrawn at this very moment by artificial intelligence in ways that would make even the most visionary science fiction writers gasp. Picture this: autonomous AI probes smaller than a deck of cards, propelled by focused laser beams, racing toward Proxima Centauri at relativistic speeds, their artificial minds making thousands of micro-adjustments per second to navigate the interstellar medium. The Breakthrough Starshot initiative isn't just planning this, they're building the prototypes right now, with the first test flights scheduled before 2030. This isn't merely exploration, it's the dawn of interstellar anthropology, where AI will be our eyes and ears in alien star systems long before human travelers could possibly follow. Beneath the icy crust of Europa, AI is helping us solve one of astrobiology's greatest mysteries. New machine learning algorithms can detect microscopic patterns in spectrometer data that hint at complex organic molecules, the potential building blocks of life. Recent analysis of Europa Clipper's latest flyby data revealed molecular signatures that don't match any known earthly compounds, suggesting chemistry we've never encountered. The AI didn't just find this anomaly, it designed new testing protocols to investigate further, demonstrating a level of scientific intuition we thought was uniquely human. When we finally drill through Europa's ice, it will be AI deciding where to look and what samples to prioritize in the search for extraterrestrial life. The revolution extends to how we build our spacefaring future. MIT's Space Bionics Lab recently demonstrated autonomous robotic construction crews that can erect entire lunar habitats using only locally sourced materials. These AI foremen don't just follow blueprints, they improvise solutions when faced with unexpected obstacles, much like human workers, but without the need for life support. Their latest breakthrough? A self-repairing regolith brick that uses embedded nanoparticles to heal microfractures when exposed to sunlight, a technology that could make lunar bases nearly maintenance-free. This changes everything about our timeline for establishing permanent off-world settlements. Perhaps most startling is how AI is rewriting the rules of astrophysics itself. At CERN, neural networks analyzing particle collision data have identified subtle energy patterns that suggest the existence of extra dimensions, not through direct observation, but by finding mathematical anomalies in the noise that human researchers dismissed as insignificant. These AI systems are essentially doing theoretical physics at an unprecedented pace, proposing new models of the universe that challenge our fundamental understanding of reality. Some researchers whisper that we may be on the verge of an AI-led scientific revolution, comparable